If oxidative stress is one thief stealing your brain's NAD+, inflammation is the other, and in many ways it's even more problematic. Chronic inflammation in the brain, what researchers call neuroinflammation, is one of the hallmarks of Alzheimer's disease. And here's what makes it so damaging. Inflammation activates a family of enzymes that consume NAD+ at extraordinary rates. We're talking about enzymes like CD38, which can degrade NAD+ so rapidly that it's been called one of the main NAD+ consuming enzymes in the body. Let's understand the mechanism here. When your immune cells in the brain, called microglia, become activated in response to damage or perceived threats, they release inflammatory signals. These signals activate various cellular stress responses, many of which require NAD+ to function. The problem is that in Alzheimer's disease, this inflammation doesn't resolve. It becomes chronic. Microglia stay activated month after month, year after year, continuously draining NAD+ reserves. It's like having a leak in your gas tank while you're trying to drive across the country. This chronic inflammatory state creates a vicious cycle that's remarkably similar to what we see with oxidative stress. Low NAD+ impairs cellular function, which causes more damage, which triggers more inflammation, which consumes more NAD+. The brain gets trapped in this downward spiral where it can't maintain the energy levels needed to resolve the inflammation that's draining its energy. It's a metabolic trap. Now, can diet really impact neuroinflammation? This is where the science gets both interesting and frustratingly incomplete. We know from numerous studies that certain dietary patterns are associated with lower systemic inflammation. The Mediterranean diet, for example, consistently shows anti-inflammatory effects in research studies. Foods particularly noted for anti-inflammatory properties include fatty fish rich in omega-3s, olive oil, nuts, berries, leafy greens, and turmeric. These foods contain compounds that can modulate inflammatory signaling pathways. But here's the challenge. The brain is protected by the blood-brain barrier, which is highly selective about what it allows to pass from the bloodstream into brain tissue. Just because a food reduces inflammation in your joints or your gut doesn't automatically mean it's reducing inflammation in your brain. Some anti-inflammatory compounds do cross the blood-brain barrier, omega-3 fatty acids being one notable example, but many don't reach significant concentrations in brain tissue. There's another issue we need to confront honestly. In established Alzheimer's disease, the level of neuroinflammation is severe. We're not talking about mild, subclinical inflammation. We're talking about a brain that's essentially on fire immunologically. The idea that dietary changes alone could significantly dampen this level of inflammation once it's established is probably optimistic. Where diet might have more impact is in prevention, helping to prevent or delay the onset of chronic neuroinflammation before it becomes self-sustaining. That said, systemic inflammation does appear to affect brain inflammation. Conditions like obesity, type 2 diabetes, and cardiovascular disease all promote chronic low-grade inflammation throughout the body, and this can exacerbate neuroinflammation. So dietary patterns that reduce systemic inflammation might indirectly benefit the brain by reducing the overall inflammatory burden. This isn't a direct mechanism, but it could still be meaningful over the long term. The other consideration is that inflammation and NAD+ depletion are interconnected with multiple other aspects of metabolism. Poor blood sugar control promotes inflammation. Oxidative stress promotes inflammation. Gut dysbiosis promotes inflammation. So an anti-inflammatory diet isn't just about specific anti-inflammatory compounds. It's about creating an overall metabolic environment that doesn't constantly trigger inflammatory responses. The uncomfortable truth is that once neuroinflammation becomes entrenched in Alzheimer's disease, it's extraordinarily difficult to reverse. No dietary intervention has been shown to achieve this. But for people who are cognitively healthy or in very early stages of decline, adopting an anti-inflammatory dietary pattern could potentially help prevent the NAD+ draining inflammatory cascade from taking hold. This is speculation based on mechanism, not proven clinical benefit, but the biological rationale is sound and the dietary changes recommended are health-promoting in numerous other ways.